This is problem number 5 from section 2.4. In this problem, they say complete the following for f of x. And they give you a piecewise function. It says determine the domain of f. Well, the domain of f is always going to be what you can plug in. Well, you can see that you can plug in 0 because it says less than or equal to x. So 0 is part of the domain. We can't plug in 3 here, but we can here, and we can go from 3 to 5 here. So we can go from anywhere from 0 to 5, so we can say the domain of this function runs from 0 to 5 and includes those endpoints. So we can plug anything into this function between 0 and 5. Nothing else, though. Part B says to evaluate f of negative 1. Well, f of negative 1, we just talked about our domain being 0 to 5. So can you plug in negative 1? Well, no, because our domain is 0 to 5, so f of negative 1 would be undefined. What about f of 1? Well, f of 1, if we plug 1 in, 1 is between 0 and 3, so we're using this function. So we're going to say 2 times 1, which is 2. And what about f of 6? Well, f of 6 is 6 in our domain, 0 to 5. No, it's not in our domain. We just looked and saw we can only plug in numbers from 0 to 5. So f of 6 is also undefined. Part C, graph f. Now, when you go to graph these, they're actually pretty easy to do by hand if they're linear type functions like we have here. So because, let's see, we don't ever go below the x-axis, I'm just going to look at this upper right quadrant here. We're going to label this 1, 2, 3, 4, 5. And it looks like we're going to go 1, 2, 3, 4, 5, 6. We'll at least go up to 6 here. So let's see what we've got. We plug in 0, we get 0. So for the first function, and I'm going to use this color for that function, and we'll use blue for the other one, just to distinguish them. So plug in 0, we get 0. Plug in 1, we get 2. So that's right here. Plug in 2, we get 4. And plug in 3, we get 6. So there's the first part. Let's do the second part now. So let's plug in 3, we get 4. So 3, we get 4. We plug in, and you know what I forgot to do? When I plug in the 3 here, sorry, this is supposed to be an open circle. I'm going to go ahead and put that there. That should be an open circle because that is not defined because of that inequality sign. But this one is, because it says greater than or equal to 3, so it is defined here. We can go ahead and plug in 4, and we'll get 5. And 5 will get 6. And those are all defined because of the inequality signs. So this is our piecewise function that we have there, and that's it graphed. Part D, is it continuous? No, it's not continuous. It's discontinuous at x equal 3. So no. It's discontinuous at x equal 3. And that's how we evaluate a piecewise function.